In this lecture, first of all, we define Dirichlet conditions. Fourier series of the function is defined as this series where a0, a and bn are Fourier constants, and this series holds only under some conditions. First one is function should be periodic, single valued and finite. Second is function has finite number of finite discontinuity in any interval. Third one is function has at most finite number of maxima and minima. These conditions are called Dirichlet condition, and this is very important question for short notes. Try to prepare this topic for short answer questions. And the integrals fx sin nx by x, fx cos nx by x are called Dirichlet integrals. This is also important for short answer questions. Just remember this definition for short notes. Then next example, find the Fourier series of the given function and reduce this equation. First we find the Fourier series. Fourier series is defined by this equation where a0, a and bn are Fourier constants. First of all, we find the value of a0 equal to 1 upon pi 0 to 2 pi fx dx. 0 to 2 pi is an interval given in the statement. Function is defined as equal to x for 0 to pi, and function is x 2 pi minus x for pi to 2 pi. Substitute the values. After applying calculation, the value of a0 is equal to pi. Then the value of an is equal to 1 upon pi integral fx cos nx. Separate this integral into two integrals as defined in the given statement. For solving second integral, we are substituting x is equal to 2 pi minus t. So dx is equal to minus dt. When we substitute x is equal to pi as lower limit, then t becomes pi. When x is 2 pi, then t becomes 0. So this limit pi to 2 pi changes to pi to 0. T cos 2n pi minus nt and minus of dt. And that negative sign take outside, and limit is pi to 0. T cos 2n pi minus nt becomes cos nt, as cos 2 pi minus theta is cos theta. Then change the limit from pi to 0 to pi. Negative sign comes outside, negative becomes positive. So second integral changes to this one. As two integrals are same, just combine these two integrals and solve the integration. Answer is equal to 2 upon pi n square minus 1 raised to the power n minus 1. Similarly, find the value of bn doing the same substitutions as in the above steps. Value of bn becomes 0. Substitute the values of Fourier coefficients in the Fourier series. This is the Fourier series of the function. For proving the second equation, substitute x is equal to 0. When we substitute x is equal to 0, f of 0 becomes 0 and right hand side is equal to this equation. From this one, pi square by 8 is equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, as we have to prove in the statement. This is the equation that we are deducing from the Fourier series. Take another example. This is the second one. Function is defined like this. Similarly, take the Fourier series. First, find the value of a0, that is equal to minus pi, by using these steps, by substituting x is equal to t in the first integral. Then find the value of next Fourier coefficient, 1 upon pi integration of fx cos nx. First split this integral into two integrals. Then apply the same substitution as in these steps in the first integral. So this changes to this integral. After doing integration, value of an is equal to this term 2 upon pi n square, 1 minus 1 raised to the power n. Similarly, find the value of bn. Calculations are not very much complicated, just simple substitutions. Value of bn becomes this. If we see the values of an and bn, we see that both these constants are 0 for n even. Then put this values in the Fourier series. When we substitute x is equal to 0, then equation becomes this, as we have to find the sum function for x is equal to 0 and x is equal to plus minus pi. Substitute x is equal to plus minus pi in this equation, so equation becomes this. This is our final answer. Another example, In this example, function is defined as pi plus x for x lies between minus pi to 0, and for x lies between 0 to pi, the function is pi minus x. First, find the value of a naught. Calculations are very simple. A naught is equal to pi. Then find the value of an. An is equal to 1 upon pi integration of fx cos mx. First, split this integral into two integrals. Then, for solving the first integral, substitute x is equal to minus t. Dx becomes minus dt. X is equal to minus pi means t is equal to pi. When x is equal to 0, t is equal to 0. So limits minus pi to 0 changes to pi to 0. Pi plus x becomes pi minus t cos and negative nt minus dt. So the first integral changes to this one. Both integrals are same. Just combine these two integrals and apply the integration steps. Answer is equal to this one. Similarly, find the value of dn by doing the same calculation, by substituting the same values. This becomes 0. Then substitute these values in the Fourier series. This is the Fourier series of the given function. This is our last example. You can solve lots of examples from any book based on Fourier series. Formulas are totally same. Just you have to practice the integration and just remember the integration formulas that you have studied in your +2 standard. Thank you.